Welcome students. Now that we have understood the topic of continuity, so let us go to our next topic, which is called differentiation. It's called differentiation. So the first question that comes to your mind when you listen to this word is, what is differentiation? So differentiation is slightly tricky because this is not an intuitive word. So you would not have heard this word in your English language. So continuity is an English word. When I hear the word continuity, I get some notion of what continuous means. But when you hear the word differentiation, it's not a meaningful word right now. So the question is, what is differentiation? What is differentiability? So on. So differentiation can be understood as rate of change. Rate of change. Now what is rate of change? So now let us take an example function. So let us take the function y is equal to f of x. So what is the meaning of this y is equal to f of x? So function is some rule which connects the variable x to the variable y. A function is a rule which connects the dependent variable and the independent variable. So once you have some rule which connects x and y, you can draw the graph of this function y is equal to f of x. So let us say that the graph of y is equal to f of x looks something like this. So let us say that this is the graph of y is equal to f of x. So now what is the meaning of this graph? That means as you go from one point to other point, so each point corresponds to the x coordinate and the corresponding y coordinate. It is x value and the corresponding y value. So on this graph, as you move in this direction, so you go through different points. Point means that you have an x coordinate, you have a y coordinate, right? You have an x coordinate and you have a y coordinate. So let us say that this point corresponds to x is equal to a. So this y value will correspond to f of a, right? A, f of a. That is a point. That means the coordinates of this point are a comma f of a. So let us call this point as a. Now as you move on this curve, so as you go through different points, as you can see, the x coordinate of this point is different from the x coordinate here. The y coordinate of this point is also different. So as you move in this direction, in the right direction, x increases and y also correspondingly changes. So as x increases, so let us say that after some time you go to point B. So you go from this point to this point. So let us say that you have gone forward through a distance h. So you have moved forward through a distance h. So if this x coordinate is a, what will this x coordinate be? It's nothing but a plus h, right? So now if the x coordinate is a plus h, correspondingly what is the y coordinate? Is nothing but f of a plus h. F of a plus h. Now if you go from this point to this point, the x coordinate has changed from a to a plus h, right? So the x coordinate of this point is a plus h. So the x coordinate has changed from a to a plus h. And the y coordinate has changed from f of a to f of a plus h. So will the change in x and the change in y be always same? No, right? So the change in x can be different from the change in y depending on where you are moving. For example, if you move from here to here, the change in x is this much, but the change in y is this much. So you can very clearly see that x has changed a lot, y has not changed a lot. So here the change in x and change in y looks very similar. But if you go here, if you go from here to here, the change in x is small, the change in y is large. So depending on the function and depending on where you measure on this function, the change in x and change in y might be different. Now rate of change means what? So what is rate of change? Rate of change of y, rate of change of the y coordinate with respect to x coordinate. The rate of change of y with respect to x is nothing but change in the value of y by change in the value of x. So that is called rate of change. So from A to B, if you go from A to B, what is the change in the value of x? Change in the value of x is h, right? So delta x is h. And what is the change in the value of y? F of a plus h minus f of a. So what is this value? This is the rate of change of y with respect to x between the points A and B. Between the points A and B. So I call this the average rate. Average rate of change of y with respect to x. So this rate of change is not the rate of change at any particular point. So it is the average rate of change between A and B. Now instead of going to B, if I stop here, B dash. So what is the rate of change between A and B dash? So you have to calculate the corresponding change in y and the corresponding change in x. So as you can see, this rate will be different from this rate. So if you go still closer, B double dash. So the rate of change between A and B double dash might be different from the rate of change between A and B. So the average rate of change of y with respect to x between any 2 points is nothing but change in y by change in x. So I hope you understand this. So if someone asks you to find the rate of change of y with respect to x for some function y is equal to f of x. So you need to ask 2 questions. The first question is, where should I measure? That is, if you measure at different points, the rate of change of y with respect to x will be different. The first question is, where to measure? And the second question is, between which 2 points should I measure the rate of change of y with respect to x? Because if you want delta y by delta x, we need 2 points. The first point has coordinates a, f of a. The second point has coordinates a plus h and f of a plus h. Then you can find the change in y by change in x. That is, between which points? So where should you measure, and from where to where should you measure? These are the 2 questions which you need to ask if you want the average rate of change of y with respect to x between any 2 given points. Now, if I ask you a slightly different question. Now the question is, what is the instantaneous rate of change of y with respect to x at x is equal to a? It is corresponding to the point where x is equal to a. What is the instantaneous rate of change? That is exactly at this point, what is the rate of change? Now if I ask you exactly at this point what is the rate of change, that means I am not giving you 2 different points. If I give you 2 different points, you get the average rate of change between these 2 points. Now if I want the instantaneous rate at this point, so what should we do? So one of the intuitive methods is that you bring B closer and closer to A. You bring the second point very close to A, so that A and B are nearly same but slightly different. The difference between A and B is infinitesimal. So if you bring B infinitesimally close to A. So if you bring this B very close to A and take A and B as points, the average velocity, the average rate of change which you get will be very much close to the instantaneous rate of change at A, because the interval is very small. So this is what we do when we want the instantaneous rate of change of y with respect to x at x is equal to A. So what we do to calculate this is, so we calculate delta y by delta x in the limit delta x tending to 0. That is, the difference between the x coordinates of A and B is made to be very small. The delta x is made to be very small. Automatically delta y also, if the function is good, the value of delta y also becomes very small. Now the ratio of those two will give you the instantaneous rate of change of y with respect to x at x is equal to A. Because we don't have 2 points. Both the points are very close, infinitesimally close. So limit. So in this formula, delta x, the change in x is taken as h. So limit h tends to 0. F of a plus h minus f of a by h is the instantaneous rate of change of y with respect to x at x is equal to A. So this is called the differentiation of y with respect to x. This is called dy by dx. The differentiation of y with respect to x. So what is the effective meaning of differentiation? Differentiation is rate of change, but slightly more qualified rate of change. Have an adjective before this rate of change. So differentiation is the instantaneous rate of change. Instantaneous rate of change. So instantaneous rate of change of y with respect to x. So this whole phrase can be removed or replaced by differentiation. So differentiation of y with respect to x at x is equal to A is nothing but the instantaneous rate of change of y with respect to x at x is equal to A, that is equal to, usually denoted as dy by dx. Dy means the infinitesimally small change in y by infinitesimally small change in x. Delta is finite change, delta y is finite change in y by finite change in x. Dy by dx is infinitesimal change in y by infinitesimal change in x. So dy by dx is limit h tends to 0 f of a plus h minus f of a by h. F of a plus h minus f of a by h. So this is the differentiation of y with respect to x at x is equal to A. So we write it as dy by dx at x is equal to A. Or we can also denote it as f dash of x at x is equal to A. Or we can simply denote it by f dash of A. So these are different notations that we use when we talk about differentiations. The dash, the suffix, the prefix, the superscript dash denotes differentiation. Superscript dash denotes differentiation. So what we are discussing now is the differentiation of f of x at a particular value A. So what we have understood till now is that differentiation means instantaneous rate of change. Dy by dx is differential of y with respect to x at x is equal to A, can be written as f dash of x at x is equal to A, or simply f dash of A. And the definition of f dash of A is limit h tends to 0 f of a plus h minus f of a by h. So this is called the value of differentiation of f of x at x is equal to A. So if this limit exists, then we say that the function is differentiable at x is equal to a. So f of x is differentiable at x is equal to a. F of x is differentiable at x is equal to a if this limit exists. So if you want to check whether a function is differentiable or not at a particular point a, you need to try to find this limit. If this limit exists, then the function is differentiable at that point. Next, when you talk about limit, you can think about the right limit and the left limit, right? So this consists of actually two separate limits. So limit h tends to 0 plus f of a plus h minus f of a by h, and limit h tends to 0 minus f of a plus h minus f of a by h. So this is called the right derivative or the right differentiation. So this limit is called the right derivative. This limit is called the left derivative. So only if the right derivative as well as the left derivative are equal and equal to a finite value L, then only we say that the function is differentiable at the point A. So if you are asked to find the right differentiation, you just need to find the right hand limit of this limit. If you want the left derivative, you need to find the left limit. So right limit and left limit. So right derivative and left derivative. So till now we have discussed the meaning of differentiation of a function at a particular point A. Now let us try to discuss the meaning of the general differentiation function. So this brings us to the first principle of differentiation. So we have seen that f dash of a is equal to limit h tends to 0 f of a plus h minus f of a by h. This is the derivative of f at any point x is equal to a. Now the general derivative function of a given function. So if you have a function f of x, so d by dx, d of f of x by dx is called the differentiation function of f of x. This is represented as f dash of x. So d of f of x by dx, d by dx of f of x is equal to f dash of x is defined as limit h tends to 0 f of x plus h minus f of x by h. So instead of a, you just need to put x. That gives you a general differentiation function. So f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. So this is called the first principle of differentiation. So you would have learned already some of the differentiation formulas in your physics. So in physics, you need some basic mathematical tools, out of which differentiation is one of them. So in differentiation, you would have learned some formulas for differentiations of certain functions. So all the formulas come from this first principle. So first, before going forward, we'll try to apply this first principle to find the derivatives of some standard functions. And if this limit exists, then we say that the function is differentiable. If this limit does not exist, then we say that the function is not differentiable. So that comes in the topic of differentiability. So now, before going to the topic of differentiability, let us first analyze the differentiations of some standard functions. So let us take some examples. Let us take a very simple example. So let f of x is equal to x to the power n. Or this can also be written as y is equal to x to the power n. So what is the differentiation of this function? Or what is dy by dx? So f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h, right? Is a formula that is equal to limit h tends to 0. F of x is x power n. F of x plus h is x plus h whole power n minus fx is nothing but x power n by h. So how do you find this limit? So h tends to 0. Here x is a constant with respect to this limit. H is the limit variable. So if this question would have been given in your limits chapter, so how would you have solved this question? So what we do is, let x plus h is equal to t. So this implies this limit becomes limit t tends to. So as h tends to 0, where does t go? T tends to x. And x plus h is t. So this becomes t power n minus x power n by h is nothing but t minus x. So this looks like the standard limit. Limit x tends to a, x power n minus a power n by x minus a. So what is the value of this limit? N times a, the constant x here, power n minus 1. So this is the differentiation of this function. So d by dx of x to the power n is equal to n times x power n minus 1. So this is our first derivation of the differentiation of some standard function. So x power n's differentiation is n into x power n minus 1. So next, let us look at some more standard functions and their derivatives. So let us take as second example, f of x is equal to a to the power x. So what is the differentiation of this by first principle? So f dash of x is equal to limit h tends to 0, f of a plus h, f of x plus h. Fx is a power x. F of x plus h is a power x plus h minus a power x by h. This is f of a plus h minus f of x plus h minus f of x by h. So that is equal to, so limit h tends to 0. So a power x plus h is a power x into a power h. So if I take a power x as common, so you get a power h minus 1 by h. So the limit variable is h. X is constant right now. So a power x can be taken out. That is equal to a power x times limit h tends to 0, a power h minus 1 by h. So this is a standard limit. Limit x tends to 0, a power x minus 1 by x is equal to ln a. So h tends to 0, a power h minus 1 by h. So the limit is nothing but ln a. So the differentiation of a power x is nothing but a power x ln a. And if you put a to be equal to e, so d by dx of e to the power x is equal to, so here in the place of a you have e, so it becomes e power x ln e. Ln e is nothing but 1 because the base is also e, so you get e power x. So the differentiation of a power x is a power x ln a. Differentiation of e power x is exactly e power x. So this is how we differentiate exponential functions using first principle. So next, let us take f of x is equal to ln x. Let's differentiate the logarithmic function. So again, the first formula is f dash of x is equal to limit h tends to 0, f of x plus h minus fx by h. that is equal to limit h tends to 0 ln of x plus h minus ln x by h. F of x is ln x, so f of x plus h is ln of x plus h. That is equal to limit h tends to 0 ln of ln a minus ln b is ln a by b. So x plus h by x by h. So that is equal to limit h tends to 0 ln of x plus h by x becomes 1 plus h by x by h. So x is a constant here because the limit variable is h. So as h tends to 0, h by x also tends to 0. So if I take h by x is equal to t. If I take h by x is equal to t. So this limit becomes limit t tends to 0 because as h tends to 0, h by x also tends to 0. Ln of 1 plus t by h is nothing but tx. So we have a standard logarithmic limit. Limit t tends to 0 log 1 plus t by t goes to 1. So you get 1 by x as the answer. So what is the differentiation of ln x? Differentiation of ln x is 1 by x. So we have differentiated algebraic function x power n, exponential function a to the x and e to the x, and logarithmic function ln x from the first principle. In the exams, if you are asked to differentiate a function by the first principle, you have to start from this formula and try to find the limit value. Now let us try to derive the differentiations of trigonometric functions also using first principle. So now let us try to differentiate some trigonometric functions using the first principle. So if you take f of x is equal to sin x, you want the differentiation of sin x. So f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. This is the first principle differentiation of any function. So here f of x is equal to sin x. So that is equal to limit h tends to 0. So f of x plus h is sin of x plus h minus fx is sin x by h. So this is equal to, so now you need to find this limit. So is equal to limit h tends to 0. So sin x plus h can be written as sin x cos h plus cos x sin h minus sin x by h. So that is equal to limit h tends to 0. So in these two terms you have sin x. So I will take sin x as common. So sin x times cos h minus 1 by h plus cos x sin h by h. So as h tends to 0, sin h by h goes to 1. So this becomes cos x. And what about this limit? So I'll separate these two limits. So limit h tends to 0. So in this sin x is a constant. So you don't need to worry about sin x. And cos h minus 1 can be written as minus 2 sin square h by 2 by h plus the second limit becomes cos x. So now as you can see, sin x is a constant. So sin square h by 2. So to neutralize sin square h by 2, I'll divide by 2 and multiply it with 2. And again I'll divide with h by 2 and I'll multiply with h by 2. So sin square h by 2, h by 2, h by 2 goes to 1. This 2 and this 2 gets cancelled. So h by 2 is remaining. As h tends to 0, this goes to 0. So this whole limit goes to 0 plus cos x. So the value of differentiation is equal to cos x. So d by dx of sin x is equal to cos x. So a similar derivation can be done for differentiation of cos x also. I would encourage you to do that. So next, let us try to differentiate f of x is equal to tan x using first principles. So if f of x is equal to tan x, f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. So this is the definition of differentiation. So that is equal to, if you apply this for tan x, so you get limit h tends to 0. So f of x plus h is tan of x plus h minus tan x by h. So if you can find this limit will be nothing but the differentiation of tan x. So how can you find this limit? So what I do is limit h tends to 0 tan x plus h minus tan x by h. I'll multiply and divide this fraction with 1 plus tan x plus h into tan x. So let us see what happens if I do that. I'm dividing with this expression. I'll multiply the expression also. So 1 plus tan x plus h into tan x, 1 plus tan x plus h into tan x. So as you can see, this part looks like tan a minus tan b by 1 plus tan a tan b. That is nothing but tan of a minus b. That is equal to limit h tends to 0. So tan of a minus b, that is tan of x plus h minus x. It's nothing but tan h. So this whole expression becomes tan h by h into 1 plus tan x plus h times tan x. So as h tends to 0, tan h by h goes to 1. That's the standard limit. And once this goes to 1, the indeterminacy has been removed. So you can directly do the substitution. So h goes to 0. So tan x into tan x is tan square x. So the answer is 1 plus tan square x. The differentiation of tan x is 1 plus tan square x. But 1 plus tan square x can be written as secant square x. So tan x's differentiation is secant square x using first principles. So in this way, you can derive the standard formulas for differentiations of various functions, various standard functions. Now what we do is, let us use the same principles to find differentiations of some complicated functions. So let us look at this question. In this question, you are asked to differentiate tan root x using first principles. So that means the given function is nothing but tan of root x. So you need to differentiate this. So f dash of x is equal to, so what is the first principle of differentiation? Limit h tends to 0, f of x plus h minus f of x by h. Now, what is f of x plus h? F of x is tan root x. So limit h tends to 0, tan of root of x plus h minus tan of root x by h. Tan of root of x plus h minus tan of root x by h. So now you need to find the value of this differentiation. So how can we find this? What I do is, I'll multiply and divide this with 1 plus tan of root x plus h into tan root x in the numerator and denominator. So 1 plus tan of root of x plus h times tan of root x. So now once I multiply and divide with this expression, so now carefully look at this expression. So this looks like tan of something minus tan of something by 1 plus tan of something into tan of something. This is tan A minus tan B by 1 plus tan A into tan B. Tan A minus tan B by 1 plus tan A into tan B. This is the formula for tan of A minus B. So that is limit h tends to 0. This becomes tan of root of x plus h minus root x. This whole expression. So divided by h into. So this is a non-problematic part. This does not lead to indeterminacy. So you can directly do the substitution. As h tends to 0, this is 1 plus tan square of root x. So this lies in the limit. So this can be separated because there is no indeterminacy in this expression. So 1 plus tan square root x is nothing but secant square root x. So this got separated. So that is secant square root x times limit h tends to 0 tan of root of x plus h minus root x by h. So let us see how you can find this limit. So now as h tends to 0, you can see that inside tan you have root x minus root x. This expression goes to 0. As h tends to 0, this expression goes to 0. So if this expression goes to 0, if you divide exactly with this expression, tan something by something as something goes to 0 goes to 1. So that is equal to secant square root x times limit h tends to 0 tan of root of x plus h minus root x by root of x plus h minus root x times h into root of x plus h minus root x. I have multiplied and divided with this. So as root of x plus h minus root x goes to 0, tan something by something goes to 1. So this expression goes to 1. Now what is remaining is this expression, root of x plus h minus root x by h. This can be very easily solved by rationalization process. So I'll multiply it with root of x plus h plus root x and root of x plus h plus root x. So what happens in the numerator? X plus h minus x. This a minus b into a plus b is a square minus b square. That is x plus h minus x. So you get h as the answer. So this combined expression and h gets cancelled. So now the indeterminacy has gone completely. So now you can do h is equal to 0 in the remaining expression. This will be root x. This will be root x. So 1 by 2 root x. So the answer is secant square root x into the value of this limit is 1 by 2 root x. So this is the differentiation of tan of root x. So this is how you can find the differentiation of this complicated function using the first principles. So in this question you are asked to differentiate x square cos x using first principles. So f dash of x is equal to limit h tends to 0 f of x plus h. F of x is x square cos x. So what is f of x plus h? In the place of x you have to put x plus h. It is cos of x plus h into x plus h whole square minus f of x is x square cos x divided by h. So limit h tends to 0 f of x plus h minus f of x by h. So if we can find this limit, that is nothing but the differentiation of this. So let us see how we can find this limit. So that is equal to limit h tends to 0. So whenever you have product of two functions, use a standard way to find the limits here. So what we do is here, if you observe carefully, here in both the functions you have x plus h, and here in both the functions you have x. So the process is something like this: x plus h whole square times cos of x plus h. So you subtract and add a term here. So minus of x plus h whole square times cos x. You subtract and add an intermediate term, that is one function replaced by x plus h, the other function as it is. So I'll subtract this and add this also, x plus h whole square times cos x minus x square cos x is as it is, and divided by h. So you can as well choose x square cos x plus h, that is your choice. But what we do is, usually we use to subtract and add an intermediate term, that is half of the function converted to x plus h, the other half as it is. So see what happens when we do this. That is equal to limit h tends to 0, x plus h whole square, in the first two terms x plus h whole square is common, times cos of x plus h minus cos x by h. I am separating the first two terms and the next two terms, plus limit h tends to 0. In the second two terms cos x is common, cos x times x plus h whole square minus x square by h. So here the indeterminacy is in this term. This is becoming 0 by 0. This is not indeterminate. This can go out. Here cos x is a constant. It can come out because the limit variable is h. So that is equal to x plus h whole square. H goes to 0. So this directly becomes x square. And limit h tends to 0, cos x plus h minus cos x by h. This looks like the differentiation of cos x, right? So this looks like the differentiation of cos x. So similarly, as we have done the differentiation of sin x, you can also do the differentiation of cos x. So limit h tends to 0. So cos x plus h minus cos x by h minus cos x by h plus cos x times limit h tends to 0, x plus h whole square minus x square by h. So now these two are very straightforward limits. This we have already done. So how did we differentiate sin x? So you have cos x plus h minus cos x. So cos x plus h can be expanded. That is equal to x square times limit h tends to 0. What is the expansion of cos x plus h? Cos x cos h minus sin x sin h minus cos x by h. And here, what is the expansion of x plus h whole square? X square plus 2xh plus h square. X square and x square gets cancelled. Plus cos x times limit h tends to 0. So if you expand this, x square and x square gets cancelled. So h square plus 2xh by h. So in this, these two terms can be combined. That is equal to x square times limit h tends to 0 cos x times cos h minus 1 by h minus sin x times sin h by h. I have separated this into two terms, plus cos x times 1h gets cancelled, and after this if you put h is equal to 0, this becomes 0, this becomes 2x. And here as h tends to 0, sin h by h goes to 1, and as we have already seen in the differentiation of sin x, cos h by h goes to 0. So this term goes to 0, this term goes to 1. So minus sin x into 1 is minus sin x. That is x square times minus sin x plus cos x times 2x. So this will be the differentiation of x square cos x. X square cos x differentiation is this from the first principles. So as you would have observed, differentiating everything using first principle is quite cumbersome. So we have some specific shortcuts by which you can find the limits or you can find the differentiation of functions very easily. So the first shortcut rule is called the product rule. The product rule of differentiation. So what this says is, if you have a product of two functions f of x and g of x, and you have to differentiate this product. So you have to differentiate f of x into g of x. So the formula is f of x times the differentiation of second function, that is the first function intact, into the differentiation of next function, plus this time the differentiation of first function into the second function intact. So f of x into g dash of x plus f dash of x into g of x. So this is how you differentiate the product of two functions. So if you want to differentiate the product of three functions, f of x into g of x into h of x dash. So what you need to do is, you need to differentiate one function at a time, leaving the other functions intact. That is f dash of x times g of x h of x plus f of x times g dash of x times h of x plus f of x times g of x times h dash of x. That is, you differentiate one function at a time, leaving the other two functions intact. So this is a general rule to differentiate product of n different functions. So even if you have 4 different functions, so what you do is, you differentiate one function at a time, leaving the other functions constant, and add all the possible terms. So this rule is called product rule. So this can be remembered easily like this: uv dash is equal to uv dash plus vu dash. That is, the product of two functions dash differentiation is first function into second function differentiation plus second function times first function differentiation. uv dash is equal to u times v dash plus v times u dash. So this is a very useful formula that you have. For example, if you want the differentiation of x square times cos x, so what you can do is, you can differentiate x square times the second function intact plus x square times the differentiation of cos x, and the differentiations of individual functions. X square is a standard function, cos x is a standard function, and for each of this, the differentiations can be derived from the first principles. So we have done some of the differentiations using first principles. So later on, we'll try to form a table of differentiations of different functions, different standard functions, and using them, you can differentiate the complicated functions. So the differentiation of x square you'll find to be 2x. So let us see how this has come from the table. So x square is the differentiation is 2x times cos x plus x square times the differentiation of cos x is minus sin x. So effectively, the differentiation of x square cos x is 2x cos x minus x square sin x. So if you would have observed in the previous video, we have differentiated x square cos x using first principles. You'll see that you got exactly the same answer. So this is a very useful shortcut in differentiation of product functions. So next, you have something called the quotient rule also. That is, if you have a ratio of two functions, f of x by g of x. So if you want to differentiate this, you want to differentiate f of x by g of x. So the formula is something like this. So in the denominator you have g of x whole square. So in the numerator you have g of x times f dash of x minus f of x times g dash of x. G of x whole square, gx f dash x minus fx g dash of x. So you can remember this easily like u by v whole dash is equal to, in the denominator you get v square. That is whatever function is in the denominator, square of that. And in the numerator you have v u dash minus u v dash. So the difference between the product formula and the quotient formula is, in the product formula you have a positive sign in the middle. In the quotient formula you have a negative sign in the middle. And to remember, you can remember it like this. So the function, the formula starts with v. So you have v square in the denominator and the formula starts with v. So vu dash minus uv dash by v square is the formula for the differentiation of u by v whole dash. So for example, so if you have x square by cos x, so if you want to differentiate this, so the answer is nothing but, in the denominator you have cos square x, the square of this function. Now in the numerator you start with v, cos x times x square's differentiation minus x square times cos x's differentiation. So x square's differentiation is 2x. So you get 2x cos x, and cos x's differentiation is minus sin x. So minus sin x into minus. So you get plus x square sin x by cos square x. So this is the differentiation of this function. So now you have understood first principle of differentiation, and you also understood how to find differentiations of products of two functions and the ratio of two functions. So again, these formulas can also be derived using the first principles. So don't think that these formulas have come from a whole different concept. So the basic concept is the first principle. So the derivations of the product rule and the quotient rule can be done using the first principles. So I'd encourage you to try that. So the derivations are not required here. So I'm not doing the derivations. Now what we do is, we'll tabulate the standard differentiation formulas. So once we have the standard differentiation formulas, we can differentiate all functions very easily. So now let us look at some standard formulas which you need to remember. These formulas have to be committed to your memory. The first formula is d by dx of x power n is equal to n times x power n minus 1. And d by dx of a constant, the differentiation of a constant is always equal to 0. And d by dx of e to the power x is equal to e power x. D by dx of a power x is a power x ln a. And d by dx of ln x is 1 by x. So we have already derived all these results. And with respect to trigonometric functions, d by dx of sin x is equal to cos x. D by dx of cos x is minus sin x. D by dx of tan x is secant square x. D by dx of cot x is minus cosecant square x. D by dx of secant x is secant x tan x. D by dx of cosecant x is minus cosecant x cot x. So these are the 10 basic formulas which you always need to remember. So d by dx of a constant is equal to 0. This is also a very important formula. And apart from this, there are some specific applications of these formulas which you need to specially remember. For example, d of x by dx is equal to 1. So if you differentiate x, you get 1 as the answer. So this is an application of this formula, but you need to remember it directly. Similarly, d by dx of x square, you have to be very quick in writing 2x as the answer. Because if you apply this formula, 2 goes forward, 2 into x power 2 minus 1, it is 2x. Similarly, d by dx of x cube, what is this? D by dx of x cube is 3 times x times square. 3 comes forward, x power 3 minus 1 is 2. So d by dx of x cube is 3x square. Similarly, d by dx of x to the power 4 is 4x cube, so on. So this is how the polynomial differentiation works. Similarly, what is d by dx of 1 by x? So here also this formula can be used. So 1 by x is nothing but x power minus 1. So for x power minus 1, what is the differentiation? Minus 1 into x power minus 1 is minus 2. It is minus 1 by x square. So d by dx of 1 by x is minus 1 by x square. Similarly, d by dx of 1 by x square is equal to minus 2 by x cube, so on. So this is how you apply the formula of differentiation for x power n. So other formulas are straightforward. Similarly, for example, if you want d by dx of 2 to the power x, the answer is nothing but 2 power x ln 2. A is equal to 2, so you get 2 power x ln 2 as the answer. So these, take a pause and try to remember all these formulas and commit them to your memory very well before going to the next topics.